As far as legumes go, as a general rule, what we're talking about is an ecosystem that encourages mycorrhizal fungi which don't live under legumes. So we tend to be looking at grass-based systems, perennial grasslands. Be good to have legumes in there for animal production, be good to have legumes in there for diversity, and because you've got diversity of root architecture and, you know, tap-rooted plants versus fibrous-rooted plants, then it's always going to be good to have a whole range of different kinds of plants in there, but we wouldn't be looking at things like straight legume crops, such as lucerne or something like that for carbon sequestration, because as a general rule they don't have any fungi associated with their roots. But we definitely be encouraging diversity. Okay, there's a bacteria that lives on legumes, which is Rhizobia bacteria, which is a different thing to the fungi on grasses. Yeah, so that's a bacteria. But the bacteria are very, very important too. We now know that mycorrhizal fungi have bacteria that grow on the outsides of those long strands I was talking about that look like hairs. They've got bacterial associations that actually do all the work. So that when the tip of a mycorrhizal fungi is doing something like converting phosphorus from an unavailable form into an available form that can be taken back to the plant, it's actually the bacteria that do the work. So it's providing an environment for other microbes. And the more we find out about soils, the more we realise what we don't know and how complex they are. And there are some bacterial groups in soil that facilitate the germination of spores of mycorrhizal fungi. There's one I think called Bacillus mycoides or something that they're now finding if you don't have that bacteria in soil, that you probably won't get your mycorrhizal fungi to germinate either. So the more we learn, the more we realise that we've degraded soils to the point that they're so simplified and they're so lacking in functional groups that it's hard sometimes to get them restarted again. So you might think, oh, well, all I need to do is get some VAM, which is mycorrhizal fungi, just buy some VAM-coated seed or buy some VAM and stick it on my seed, put it in the soil or spray it out or whatever and everything will be okay. But you haven't got the other functional groups in soil that those fungi need to be able to grow and live in that soil, then they'll probably just die. So the advantage of doing something like re-establishing perennial grasses is that you re-establish a very diverse microflora that lives in association with those plants. 90% of biological activity in soil is around the rhizosphere, and that's just like the zone right next to a plant root. It's only about 1 millimetre wide, and that's where most things live in the soil. So if you want to have lots of things living in soil, you need lots of rhizosphere. To have lots of rhizosphere, you have to have lots of roots, and to have lots of roots, you have to have lots of plants. So have your system where you have just an annual plant growing for, say, 6 months of the year with a relatively small root system compared to a perennial, and then bare ground for another 6 months of the year. Compare that to having perennial grasses with large fibrous root systems going down much deeper, much wider, much more complex, and a much larger area of that soil volume being explored by plant roots. You're going to have much higher levels of biological activity there.
In those perennial grasslands, can you do anything to feed the existing microflora that's there to help them?
Okay, so the question was, in perennial grasslands, could you feed the existing microflora? And I think this is where the whole thing of things like compost teas, microbial inoculants, or using things like, seaweeds and fish meals and all that sort of thing, I think that's where the future is for doing that. You're saying, would they already, the ones you already want, be there?
The ones that are left that are possibly simplified because of our past management structural practices. How do we promote them without, I'm not saying we don't introduce new ones, but if there's some that are symbiotic with the existing grasses that are there that have been there since millennia, how do we promote them?
Okay, so the question was, if we simplify the system, then how do we get back all the complex? Well, I mean, we could have lost millions that we don't know about, or hundreds or thousands or whatever. We probably don't know what we've lost in soils. The thing about microbes, though, is that it's a lot to do with the environment. Louis Pasteur, who was the microbiologist, that the word pasteurisation comes from his name, he spent his whole life studying microbes, and he said the terrain is everything, the microbe is nothing. So even someone whose whole life was about microbes and microbiology admitted that it's the environment that's the important thing. So if you consider something like you had a room full of people and you introduced a cold virus or something like that, not everybody would get it. Not everyone would get a cold, because some people would have an immune system that would be able to resist that, and other people would probably get it quite severely. So it would depend where those germs landed and what state they found that person in as to whether they were able to develop in that person or not, if you know what I mean. So the environment in your body will determine to some extent what microbes can proliferate, and the environment of the soil to a large extent determines what microbes will proliferate there. So when we want good microbes to proliferate in the soil, if we provide an environment that's conducive to that, the chances are that there'll be more microbes there than more groups than we'd ever be able to measure or know. So that as many, I think that maybe comes back to the question of legumes too, is that if you had a very diverse grassland with lots of different sorts of herbs and grasses and things in it, then there's going to be different chemical signatures come out of the exudates. Every different plant has different chemical exudates and will have a different rhizosphere flora around it. So that would be the way to get diversity below ground, would be to have diversity above ground, as well as perenniality. So perenniality would be the first thing, and then diversity within that perenniality would be what you'd be looking for.
So to increase the amount of activity in the soil, you basically increase the amount of roots in the soil.
Okay, so the question was, to increase the activity in the soil, you increase the amount of roots. That's yes to a point, but those roots also need to be active. So you need to manage those above ground plants in such a way as to, you want actively growing roots, because mycorrhizal fungi, the hyphae only live on average 10 to 12 days, and the spores will only germinate near actively growing roots, so that they're not going to be germinating up near the surface when the roots are down 60 centimetres, so that's where the grazing management comes in, and also the question about the dead grass. So yes, grazing management is exceptionally important. For one thing, you want the plants to develop a lot of green leaf before they're harvested, so that your solar panels are working properly, lots of photosynthesis, lots of carbon fixing happening. Then you want grazing to be concentrated in a short time, so that it's effective, like fairly efficient in taking off those green leaves, but also because if it's a short graze with a lot of animals, it means you're going to have a long rest. And when those roots are grazed, when the tops are taken off, a large proportion of the roots will prune into the soil, because grass plants always equalise their biomass. Because the roots are active and respiring and using energy, they can only use energy provided by the tops, like fixed in photosynthesis, so that when the leaves are taken off, the plant will just prune a whole heap of roots into the soil just to balance the top and the bottom of the plant. And that means you're putting a whole lot of organic matter into the root zone, where it will become labile carbon, but in that situation that promotes a lot of biological activity and enhances the humification process when the new roots grow through. So if those plants are grazed, livestock moved on, they quickly recover because they've got good root reserves, good crown reserves, lots of active new roots, promoting lots of mycorrhizal fungi and lots of food for all the bacteria and everything that are in association with that. So grazing management, extremely important for firing up the biology.